Hi, this is Kate, and we're learning about exponential growth. Congratulations, you have won the lottery. You have two options for how you're going to receive your winnings. In option 1, you'll get $1,000 the first week, and every week after that you'll get $200 more. So initially you'll receive $1,000, the next week $1,200, the next week you'll receive $1,400, and so on. With your second payout option, you'll only receive $3 the first week, but the amount you receive is going to double every week after that. So initially you'll receive $3, in the next week 6, in the next week 12, and so on. Which option would you choose? I'm not going to tell you yet which one is better. But it certainly looks like, at least in the beginning, you're getting more money with option 1. You might recognize payout option 1 as a linear function. As the weeks go on, we receive $200 more, plus 200, plus 200. This is the hallmark of a linear function. You keep adding the same amount to get the next amount. You're probably already pretty familiar with linear functions, which equation relates the week number to the payment you receive that week. That would be choice C. The payment has an initial value of $1,000, and $200 is added for every week in the future. This linear function has a y-intercept of 1,000 and a slope of 200. If we were to graph all the possible payouts for all the possible weeks, the graph would look like a line. That's why it's called a linear function. In payout option 2, as we move into the first week, we get $3 more. Into the second week, we get $6 more. And into the third week, we would add 12. We don't just keep adding the same thing to get to the next week. This function is not linear. You've probably noticed that even though we don't always add the same thing, we do always multiply by the same thing. 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. In order to develop an equation, we're just going to write out the expanded form. 6 is 3 times 2. If we multiply that by another 2, we get 12. And multiply that by another 2, we get 24. In week 4, the payment would be $48. How should we write out the expanded form of $48? We'd want to take our previous amount and multiply it by another 2. Now look at this expression carefully. 3 times 2 times 2 times 2 times 2. We have a more efficient way to write 2 times 2 times 2 times 2. What is it? Which expression is equivalent? A more efficient way to write 3 times 2 times 2 times 2 times 2 is 3 times 2 to the 4th power. So if I rewrite these other expressions with exponents, they would look like this. Because we can write these expressions with exponents, this is called an exponential function. We noticed previously that it was not linear. You might have been thinking, well, if it's not linear, what is it? This is exponential. Which expression could we evaluate to figure out how much we would be paid in week 10? In week 10, we'd want to use 10 for our exponent. So if we use W to represent the week we're in and P to represent the payment, which equation represents the relationship between W and P? That would be choice D, because we raise 2 to the power of whatever week we're in, multiply by 3, and that tells us the payment for that week. The two numbers that determine the behavior of the exponential function are the 3, which was the initial value or the starting value, and then the 2 we call the growth factor that tells us what we multiply by to find the payment for subsequent weeks. So we started out by asking, which option would you choose? The linear function is just going to keep adding $200 every week. So in week 4, 1,800, week 5, 2,000. The exponential function will double the amount every week. So in week 4, we'll earn $48. In week 5, we'll be paid $96. Let's project this out a little bit. In our linear option, in week 9, we'll receive $2,800. 200 times 9 is 1,800, and then adding 1,000 to that, 2,800. What is the payment in week 9 for option 2? And remember to calculate the payment, we're using P equals 3 times 2 to the W. In week 9 under option 2, we'll be paid $1,536. Now something important is going to happen here in week 10. In option 1, we'll get $200 more, so $3,000. In option 2, we'll double that amount, and we'll get $3,072. Week 10 is the first time we're receiving more money under option 2 than we did under option 1. In the linear function, we just keep adding the same amount every time the graph looks like a line. In the exponential option, we double the amount every time. So what I really want to point out to you here is this behavior of exponential functions. They start out growing slowly. You may have thought that option 1 was the better option because you got more money to start out with. But look, in option 2, even though it starts out growing slowly, after week 10, you're making more money than you were in option 1, and the amount you receive really skyrockets after that. The hallmark of exponential function is how quickly they grow. So if we want to have a little fun, we can see how much we would make in the last week of the year, in week 52. Under the linear option, 200 times 52 is 10,400. Add 1,000 to that, 11,400. That's a good chunk of change. But check this out. In week 52, under the exponential function, we're going to raise 2 to the 52nd power. That's a huge number. 10 to the 15th is more than trillions. It's in the quadrillions. This is a 1, a 3, and a 5, and then 14 zeros after it. I'm pretty sure this is more money than is in circulation on the entire planet. So this question turns out to actually be kind of ridiculous. You would never be offered this option in a lottery. But it illustrates how out of hand exponential functions can get if they're allowed to grow for a long time. This is Kate, and we've been learning about exponential growth.